So we take this is one of the example for the initial value problems using the Laplace transform basically. And then so we have this is a second order ODE, non-homogeneous again. So this is a non-homogeneous term, and they provide the two initial conditions with the y0 equals to 2 and y prime 0 equals to 1. So as we mentioned on before that, so we have three major steps over here to get the solutions. So the first of all, so what we did here, we try to do the Laplace transform of the given ODE. That means first we try to Laplace transform of the both right hand side and the left hand side here. And the next, for this one we are using the linearity, so that's why we're going to Laplace transform for the y double primes as well as the y over here. And the right side here is very easy, you just Laplace transform for the exponent negative t, and this is somehow you will get this one, yeah. So for Laplace transform for your second order ODE, like this one, so basically you will get for this solution. And this is what we mentioned on the earlier. So this is just a Laplace transform for the second order derivative. And for this one, your y, actually Laplace transform of y, you will get the ys. And until this stage, you have the y0, you have the y prime 0. Basically, this is what the value you're going to substitute inside this the Laplace transform. So this is what next. So this is what we say. So we just substitute the y0 equals to 2. So that's why I have this 2, and y prime 0 actually is equals to 1. So that's why this is what we have the 1 here. So what we do on this one, the next step, we try to simplify, meaning that we try to simplify this thing. We have the ys and the ys, so that's why we just factorize it like this, because we want to express the ys equals to something like this one, so that's why we just factorize. And then we have this one, we just move on to the right hand side, just divide. So this is what we have here, and because of that, this is our ys here. So for step number 3, basically you want to get back what is your yt for this one, the yt. So that's means you need to inverse Laplace transform for this. So before we start, so we want to do the inverse Laplace transform, we notice that this is the partial fraction form. So that's why we're using the partial fractions to get the to reduce the this fraction into the partial fractions, and the things will become easy. So we just equalize the numerator and the denominator, and then we just compare to get the a and the b and the c values, and this is what we try to compare it. So it's very easy, we just let the first s equals to -1, so that's why we cancel all the term and left with the a's over here. So the s -1 actually you just substitute inside the expression on the top here. So -1, that means this is 0. So -1, so we have the 5, and then this one as well. And then we get an a over 1 over 5. The same thing for this one, we try to use the s equals to 0 because of for the simplicity. So we just substitute x equals 0, that's why it's 0, 0, we have the 2, and then your a, this one the 0, and that's why you have 4a, and this is the bs, so the s0, then 0, then we have only the c over here. And try to rearrange, you will get the c values, simplified. The same thing for this one, we just select any value for the s here, but for easier case, we use the s equals to 1. And we just substitute all the s in the function here, equals to 1, and this is what we have here. Because we know already the a values and the c value, so we just substitute back. This is the a value and this is a c value, we just substitute inside this one, and then simplify. I believe that later we'll get the answer for b. And you have the a, you have the a, you have the b, c, you have the b values, and all this value later we will use substitute back to the original expression, and this is somehow we have this one, and then we will be using this to perform the inverse Laplace transform. And it sounds like very easy. This is what we learned on the previous weeks. So you want to determine the yt, that means we just inverse Laplace transform for each of them. So for this one, it's very easy. I believe that you will get the exponent form, but for this one you have to split into 2 terms first. Yeah, so this is somehow you have this, and inverse Laplace transform for this, you get the negative exponent, and this one you get the cos function, and this is what you have the sine function. And with this, and this is the solution for the initial value problem for the particular non-homogeneous equation. And this is very simple, we're using the Laplace transform.